Okay, good morning, everybody. So we are going to be looking at page 35 in your notes packet. So if you would open up to the page 35, these are not just things that we're just going to talk about, and you might take a couple of notes here and there. So you have heard of different kinds of functions, and these are just the graphs of the basic functions that we tend to use in pre-calc. So obviously this is a line. We've talked about this. So a line has a slope and it has a y-intercept. In this case, the slope is up 1 over 1, so the slope is 1, and the y-intercept is 0, 0. Okay, so you know that. We don't really need to talk too much about that. Now, the quadratic function is a parabola, and the basic x squared starts here at 0, 0. Now, this is something that is new that I want to discuss with you, and I would like you to write this down off to the side or underneath. When you're plotting a quadratic, a parabola, we go by what we call this 1, 4, 9 method. Please write this. And then I want you to put a plus or minus, and a plus or minus, and then do 1, 2, 3. So we call it the 1, 4, 9 method, but again, it's always 1, 4, 9, and then we always have a plus or minus, and this will go in order 1, 2, 3. So what does this mean? What it means is we're going to start right here at the turning point, which in this case is 0, 0. This tells us how far, and let me put this in a different color, how far up or down we're going to go. And this tells us how much to the left or to the right. So put those little arrows there, and then I'll explain it so it makes sense to you. Okay, and it's not hard. So basically, we start at the origin. We go, in this case, since this is a positive one, we're going to go up 1, and then here we go to the right one and to the left one, okay? So we go up 1, left 1, put a dot, right 1, put a dot, and that's how we got these 2 dots right here. Then what I would do, this 4 means I would start again at the turning point. I would go up 4, and then I would go left 2, put a dot, right 2, put a dot. Now, these aren't on this graph, but I'm going to put them there. Okay, so right there is one, and right there is the other. Okay, so again, from the turning point, up 4, left 2, put a dot, right 2, put a dot. And then you can kind of figure out that here we'll go up 9, left and right 3. So I'm going to start here at the origin. I'm going to go up to 9, left 3, put a dot, right 3, put a dot. Now, that works for pretty much most parabolas. I am going to, notice I said the word most. So when it changes, I'll address it at that time. I just think right now, let's just leave it as it is. So this will work for most parabolas, this 1, 4, 9, plus or minus 1, 2, 3. Okay, the cubic function. Let's go over here to the cubic function. Notice that this turning point, so to speak, it's not really a turning point, but remember we talked about concave up and down. To the left of that, do you notice that the function is concave down? And to the right of this 0, 0 is concave up. So when there is a change in concavity, this is called a point of inflection. You don't need to know that right now. But that will be kind of like as important as our turning point is here in the quadratic function. Okay, so from here, we will always go to the left one and down one. And then we will always go to the right one and up one. So these 3 points are extremely important, okay? So again, from this center point, this point of inflection, left 1, down 1, and right 1, up 1, okay? All right, absolute value down here is like a V. It's really super easy, okay? So normally, we would start the V, the point of the V, at 0, 0, and then the slope of this line is -1. So look, up 1, left 1, up 1, left 1, up 1, left 1, up 1, left 1. And this is a positive 1. So up 1, right 1, up 1, right 1, so on and so forth. Okay, so that you're going to need to know. So this, and this, these are very common graphs that we will see in pre-calc, and you're going to need to kind of commit their behavior, as we call them, to memory. All right, now let's look at the next one, the square root function. So this is y equals radical x. Now, this is really kind of like a sideways parabola. So I want you to notice something. So from here, this origin, the 0, 0 point, is really like the turning point right here. And watch what we do. We go to the right one, up one. And then watch, we go to the right 4 and up 2. Okay, so it's basically 1, 4, 9, but instead of going up first, this is really becoming your horizontal and this is becoming your vertical. Okay, so again, to the right 1, up 1. To the right 4, up 2. Then here I will go to the right 9, up 3. So let me put that point in there. Okay, so it would be right here, and we would be going to the right 9 and then up 3. Now, that's a comma. One thing you need to understand, remember how I said that this is a sideways parabola? Notice we don't have the bottom part of that parabola. Okay, a square root is only the top part. Okay, so we will not have this bottom part in a square root function. Okay, all right, now the next cube root function, let's cross that baby out. We don't need to know anything about that. Okay, so let's turn the page and let's look at page, where are we at now? Page 36, right? Okay, so the ln of x, the biggest thing you really need to know is this point right here, and I'd like you to label that. It's not labeled. That is 1, 0. Okay, 1, 0. Oops, now the other big thing that you need to know, and then I'm just gonna, bell rang, is that we have an asymptote here. So notice that the graph does not cross over the y-axis. Gets closer and closer to it, but it does not cross over it. Okay, so that's important to know for your ln. The next one that we look at is the e to the x. Now, to be completely honest with you, the things that you really need to know about e to the x is that it does pass through 0, 1. So maybe whether you kind of star this or highlight that, that's important. This point here, 1, e, isn't really necessary. I'm just going to be honest with you. But 0, 1 definitely is, as is 1, 0 over here. Okay, and as with the ln, we had an asymptote here going to the y-axis. We have an asymptote here going to the x. I know it looks like it hits the x-axis. It does not. And you learned this in Algebra 2 last year. So this e to the x graph is going to skim the x-axis but not touch it. So the x-axis is an asymptote. And remember, if the x-axis is an asymptote, its equation is y equals 0. All right, the last one then is 1 over x. Again, this is kind of a cruddy picture, so let me just see if I can sort of, here, wait, let me put in a different color for you. I mean, it's generally okay, but you have an asymptote on the x and the y-axis over here, okay, and the same thing here. So they're crisscross from each other, diagonally across from one another, here and here. Okay, but see here it looks like it actually touches the y and the x-axis, and here as well it does not, so it looks more like that. Okay, all right, so just please make sure that the graphs that were on page 35 and 36, except for obviously that the cube root function, I'm sorry, on the bottom of page 35, you don't need to know that. But you do need to know the behavior of the other ones, and you also need to know the important points that I pointed out. Okay? All right, so the next thing, and this should be pretty easy for you because I know that we did this last year in Algebra 2, transformations. Okay, so a shift is when something moves up, down, left, right. So if you have a number outside of parentheses, that is a shift up or down. If you have a plus sign, it's a shift up. If you have a minus sign, it's a shift down. Okay, if the C value in this case is inside the parentheses, then that's a left-right shift. But just remember, it's opposite directions. So this is minus C. That means you will shift right. Plus C, you will shift left. Again, I'm not telling you anything new. You should know this already. If you want to highlight anything, go for it. Now this is a little bit new. We're going to do a little bit of it, narrowing or widening. So if you have a number in front of a function, and this will make more sense when I go through an actual problem. If that number is bigger than 1, the graph actually narrows, it gets skinnier. And again, I'll go over that when we get to a problem. Whereas if the number here is between 0 and 1, that means it's a fraction, right? So if this is a fraction, it actually widens the graph. So it's sort of like opposite of what you would normally think, kind of like up here with the horizontal shifts, opposite signs. Here, if the number is bigger than 1, it narrows. If it's between 0 and 1, a fraction, it widens. Okay. All right, then we have the reflection about the x-axis. I don't know if you really need to know this all that much, to be honest with you. I think you can eyeball it better. But basically, you would negate the function. If we are reflecting around the y-axis, the x gets negated. Okay? Alrighty, so here are just some examples of some shifts. So just remember, if this is essentially what you want to think of that as is just the graph y equals x squared, and yet it's shifted. Okay, and it's shifted 2 to the right and then down 1. Okay, so your normal x squared picture, remember, would kind of go like this. Okay, and so this turning point got shifted to the right, down 1, and there is your turning point. Then remember, we do 1, 4, 9. So we go up 1, left 1, right 1. Okay, now they don't have it in this picture, but the next one I would go up 4, left 2, right 2. Okay, and we'll do something like that, so don't worry about that. All right, so we have an absolute value. Remember, an absolute value is v. Value is v. That's how I remember that. And we are shifting to the right 1 and up 2. Okay, and again, let me just put this in a different color. Remember, normally your v is right there at the origin, and we have a slope of -1 here, and we have a slope of +1 there. Okay, so we are shifting this point to the right 1 and then up 2. Okay, and remember, slope of -1, slope of +1. All right, this guy right here. So we have a shift down, but this tells us that we are flipping over the x-axis. Okay, so the way I really remember it is if you have a negative leading coefficient, then your parabola is going to open down instead of up. Okay, all right, kind of the same deal here. So I have a negative leading coefficient. So instead of the v pointing upwards, it's going to point down. And then remember, the v usually starts at 0, 0. Well, I'm going to move 2 units to the right and 1 up. And then again, we have a slope of 1, and here we have a slope of -1. Okay, now anything that I'm saying that you feel would be helpful if you wrote it down, put it in your notes. Pause me, you can always turn me back on. All right, let's turn the page and look at. All right, so then these last two, these have to do with our stretches and our shrinking, so to speak, I guess, if you will. What was the terminology that I used? If you have a narrowing or a widening. So let's just look at this one here. Okay, the negative just means I'm opening down. So let's just kind of, for argument's sake, I'm going to just like put my arrow over that because I'm going to disregard it. I know the negative means I'm opening down. Let's look at the 2. Now, most people would think, oh, it widens, but what it does is it actually stretches it down. Look at the difference here. I went from a -1 to a -3. That's a distance of 2. Okay, so everything gets stretched, and because it gets stretched, it narrows out your parabola. Okay, and then we also shifted to the left 1 and down 1. So there's our new turning point. Now here, kind of the same deal. I have a negative, so instead of the V opening up, I'm going to open down. That's what these are doing. But I'm actually going to widen, and I'm widening. Look, this is my widening. okay? So dotted is the original, just shifted to the right one and up 2. But the widening process brings it out like that. And again, I think it'll be easier once we go through an actual example. But just look at the terminology. We have a vertical narrowing by a factor of 2. Here we have a vertical widening by a factor of 1/2. That's how we would write that. Okay, and you can look this over. You know that that is basically everything that we did last year as well. Okay, so at this point, turn to page 39, and this is what I'm going to ask you to do, and it's on Google Classroom, but you are going to do 39 through 43, just the odd numbers, and all you're doing, read the directions up at the top of page 39, sketching the graph, okay? I would probably suggest that you just continue to listen to me for 1 and 3, and then after that, go out on your own, pause me, work them through, and then you can turn the video back on just to get all the answers, okay? All right, so this first one is a parabola, right? Because I have a square term. And I know normally the parabola would start here at 0, 0. And remember, we would do that 1, 4, 9 method. So we'd go up 1, left 1, put a dot, right 1, put a dot, up 4, so on and so on. Okay, but I have a shift here. So what I usually try to do is I try to start by finding that center or that turning point. Okay, so what this is saying is my turning point is going to be moving 3 to the right, so that'll bring it at a positive 3, and then up 1. That's my new, I'm going to just write TP for turning point. Okay, and that is a P. Alrighty, so let's plot that. So we have 1, 2, 3, 1, and there is your turning point. Okay, so here's where the 1, 4, 9, plus or minus, 1, 2, 3 comes in. Okay, so from this turning point right here, I'm going up 1, left, put a dot, right, put a dot. Okay, all right, so let's do that. So left and right. Now, the next thing I'm going to do is I'm going to go up 4 to the left and right too. But always start counting from the turning point, okay? So 1, 2, 3, 4, right up here. And then we're going to go left 2, put a dot, right 2, put a dot. Okay, so go ahead and do that. And then, again, I'm going back to the turning point right here, and I'm going to count up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, right up there at the top. And then I'm going to go left and right 3. So it's going to go like this and like this. This is what I would want to see on a test, okay? And then from there, you can sketch your graph. And there's the graph of f of x. Okay? All right, so that's not so bad, right? So let's look at number 3. Alrighty, there's number 3. I got a little lost there. Okay, so I am going to go to the, whoops, I don't have my pen on. I'm doing really good here, aren't I? All right, so we're going to go to the right 2, and then we're going to go up 5. So my turning point is going to be 2, 5. So let's plot that 1, 2, 1, 2, 3, 4, 5, right there. Okay. Now, this is where it's going to get a little tricky. It's not tricky. What am I talking about? It's really not. So remember how we had that 1, 4, 9, okay, plus or minus, and then we've got 1, 2, 3. Write that down. Okay. So here's where this widening, narrowing thing is going to hopefully make sense. This number here, remember, it's larger than 1. So it's actually going to narrow out the picture. So narrowing it out, in this case, since my parabola is pointing up because this 2 is positive, it's going to make it taller this way, so to speak, okay? And the way that happens is this 149, remember that 149 represents a vertical distance, right? And this represents a horizontal distance. So when we have a lead coefficient that's not a 1, what we do is we're going to take our 149, each one of those numbers, and we multiply it by whatever that leading coefficient is, which in this case is a 2, right? That's what I've got right over here. Okay, so then basically what I'm going to be doing is instead of going up 1 to the left and right 1, I'm going to be going up 2 to the left and right 1 from your vertex, okay, your turning point. So I'm going to go up 1, 2, and then I'm going to go left 1, right 1, okay? All right, so let's do that. So up 2, left 1, right 1, okay? Now, always from the turning point, now I'm going to go up 8. I'm going to run out of room, guys, sorry. Okay, so we're going to go up 8 left and right 2. And this is where that stretch comes in, okay? So I'm going to go 1, 2, 3, 4, 5, 6. I'm going to just, kind of take a eyeball glance here. And let's say there-ish. And there's no way, by the way, not on this graph anyway, I can't go up 18. I'm totally out of room. Okay. So let me just connect these. And hopefully you kind of get the general gist that this parabola has narrowed out. Okay? Right in here, it's narrower. Because what this 2 is doing, which is this leading coefficient, is stretching this up twice as high. And think about like a rubber band. When you stretch it out, it becomes, the circle that the rubber band, creates becomes a lot narrower the more you stretch it out. Okay, so that's what I wanted you to kind of see. All right, so then what I would like you to do is do 5, 7. What else do we have here? I had you going up to page 43. So you're going to do 5, 7, 9, 11, and 13. If you look on page 43, there are 2 questions at halfway down the page. You don't need to do those. Okay, we're going to stop at 13. Okay, now remember the important points that I mentioned to you. So if you have to go back and look in the notes, from like page 35, 36, 37, 38, go ahead and do that. Pause me, go ahead and look at everything, and then you can unpause me and check your answers. Alrighty, so, oops, that's number, okay, so for number 5, that's going to be, I'm going down 7. That's why I've got this point right here. And then just be careful. Remember from there, I told you to go up 1 to the right 1, and then go down 1 to the left 1, like that. And then your picture is going to behave, this part doesn't have to be perfect, like that-ish. Okay, but those 3 points need to be there. You must be going from this, remember I called it a point of inflection, but this, center point, if you will, for right now. Up 1 to the right 1, or you can go right 1, up 1, it doesn't matter. And then from here, down and to the left. Okay, so you need to have those 3 points. Okay, so let's look at number 9. We've got a cubic. We're going to be moving to the right 7 and up 2. So 1, 2, 3, 4, 5, 6, 7, up 2. So there is your point of inflection. Now remember from there, go up 1 to the right 1 and go down 1 to the left 1. And then you can just sketch the general behavior of the curve, which is like that. Okay, that's all that's necessary for that one. All right, so we got another cubic again. So I'm going to go to the left 6, and then I'm going to go up 4. So 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. And remember, I'm going to have those 2 points. Okay, and we're going to go like this, and we're going to go like that, and there we go. Okay, so I love 13 because 13 is one like we kind of really haven't done. I showed it to you way back in the beginning of the video, but all right, so I have a shift to the left and then I'm going down 2, right? So I'm going to shift to the left 1 and down 2. So there's my starting point. Now remember, a normal square root will look like this, okay? And then if you recall, what I said for you to do is from here, we go out 1, then up 1. Then we would go out 4, up 2. Then back from here, I'd go out 9 and up 3. Okay, so this is a sideways parabola, but we're only doing half. We're not doing this bottom half here. Okay. All right, so then from here, I'm going to go to the right 1, up 1, and put a dot right there at 0, -1. Okay, just like that. And then I'm going to go back to this starting point again, and I'm going to go out 4, up 2, and put a dot. Okay, so 1, 2, 3, 4, 1, 2. So right there. Then lastly, go back to that starting point and go out 9, up 3. Okay, so right there. And that is what your radical equation would look like. Okay? All right, so now that we're all done with that, your homework for tonight is to do page 39 to 43, which is what we just finished, but we did the odds. So tonight your homework is to do the evens. Please also make sure that you have taken notes on all of this in your notes packet. Okay, you're insane not to.